This video shows the solution in case there is no point of interest when solving for the function of the best fit quadratic curve given a dataset. Welcome to Numerical Solutions to C Problems. The approximate approach of curve fitting needs to minimize the errors, if not zero it out. And with this method, the concept is to have the positive errors balance out with the negative errors so they can cancel out. The definite algorithm of group averages starts by dividing the dataset into two tables. In case there is an excess pair of coordinates, the first table would absorb it. Next is to take the summation of the x and y values in order to solve the average of each variable. Having an average x and y values, place them into the slope-intercept format of a linear function. Then through simultaneous equations, solve for a and b. Then again, these variables are placed into the required function. With a given dataset, we are to determine the best fit line and best fit quadratic and exponential curves. And instead of using separate tables, the solution will be much shorter and procedure will be more efficient if an all-in-one table is used. The standard table has the columns for x and y, which are the only parameters we need in figuring out the best fit line for the set. When we look for the best fit quadratic curve, what we needed are capital X and Y, taken from a point of interest. Say for this problem, we use the data point 6 and 62.15. So the transformed function of capital X is x plus 6, then capital Y is taken from y minus 62.15 all upon x minus 6. Then for the exponential curve determination, the same independent variable x is used. However, y is transformed from logarithm of y. So let's start filling out the table. From the third column, we have 0 plus 6, which is 6. And the same simple addition of 6 to x is used all throughout the data points. The following column involves both x and y with the function y less 62.15 all upon x minus 6. So plugging the old x and y into the function, we get the following results. Easy as it looks, be extra careful when placing your figures, as it is hard to trace errors in tabulated answers. The next column only uses y with logarithm, so it is also easy to fill out the last column with the following results. The next step is to take summations of each column. Total x is 15, while total y is 173.55. Capital X has a total of 45, then capital Y is 35.325. And lastly, y for exponential curve is summed up to 5.7477. Then since there are 5 data points involved in the first table, we can divide all total values by 5, giving 3 for x and 34.71 for y. Also 9 for capital X and 7.065 for capital Y. And then, y for exponential curve is averaged at 1.1495. With a table fully completed and referring to the format y as equated to ax plus b, we extract figures for the different functions. For the first equation of the best fit line, those involved are x and y. So the function is 34.71 as equal to 3a plus b. For the best fit quadratic curve function, the involved figures are capital X and capital Y. So the format becomes 7.065 as equal to 9a plus b. Lastly, for the best fit exponential curve, which involves figures of x and exponential y. So the first function is 1.1495 as equated to 3a plus b. Let's move to the next half. So the table starts with x of 7.5 until 13.5, and the additional columns remain the same. The third column contains capital X values from x plus 6. Then right after is capital Y with the function y minus 62.15 upon x less 6. The last column is for exponential y, which is solved by logarithm of y. Again, take the summation of values in each column, where x has 52.5 and y is 493.15. Capital X's total is 82.5, whereas capital Y is 41.01. And lastly is the exponent of y of 9.938 total. With these values, we take the average by dividing the total by 5. So the average of x is 13.125, and average y is 123.2875. For capital X, there is 20.625, and capital Y is 10.2525. Y exponent's average is 2.4845. Now let's extract out figures for the second equations of each function. For the best fit line, use x and y. So the function is 123.2875 as equal to 13.125a plus b. For the best fit quadratic curve, we use capital X and y. So the function is 10.2525 as equated to 20.625a plus b. The best fit exponential curve uses x and exponential y. So the function is 2.4845 as equal to 13.125a plus b. Now let's tackle each function separately. From the extraction made earlier, we have the two functions for the best fit line as written, and we are to solve for a and b simultaneously. If we subtract these functions, we get negative 88.5775 as equated to negative 10.125a. So a is then solved as 8.7484. With this variable known, take equation 1 and plug it in to have 34.71 as equal to thrice of 8.7484 plus b, where b now is 8.4648. So the best fit line function is y is equal to 8.7484x plus 8.4648. Now we solve for the function of the best fit quadratic curve. The extracted functions from both tables are as follows, and we subtract them to simultaneously solve for a and b. The difference is negative 3.1875 and negative 11.625a. So by dividing these two by negative 11.625, we get a as 0.2742. Plug this value into any function. Say we take the one from the first table again, and we get 7.065 as equated to 9 times 0.2742 plus b. So b becomes 4.5972. To solve for variable c, we are to generate an equation which is c, and that is through the quadratic function, where x and y use the point where the curve exactly passes. The third function is then 62.15 as equal to a times 6 squared plus b times 6 plus c. But then we also plug values of a and b. So the function becomes 62.15 as equal to 0.2742 times 6 squared plus 4.5972 times 6 plus c. And this is simplified as c equal to 24.6956. With a, b, and c already identified, we can conclude the function for the best fit quadratic equation as y, which is equal to 0.2742x squared plus 4.5972x plus 24.6956. For the best fit exponential curve, the extracted functions from the two tables are shown, and we are to manually solve for the variables through subtraction. The result is negative 1.335 as equal to negative 10.125a. A is then solved as 0.1318. But then, taking small a is e raised to capital A, which is 0.1318. So a is 1.1409. With a plugged into the equation from table 1, we get 1.1495 as equal to 3 times of 0.1318 plus b, where b is 0.7541. Small b is then e raised to 0.7541, where this is simplified as 2.1257. Thus, the best fit exponential curve function for the dataset is y as equal to 1.1409 raised to x multiplied by 2.1257.